Okay, before we start the topic for the day, let us do a recap, okay? So we will take a mind map and then discussion. Okay, let me just create a new mind map here. Right. So let's talk about big data, guys, right? Talking about big data. And as part of this big data, we started discussing about the definition, right? The definition can be explained using 4 V's. The first one is volume, velocity, variety, okay, we have veracity, we also have variety. Okay, we'll forget that. Yeah, so we have 4 V's. Then when we talked about big data, we also have to see the challenges pertaining to big data, right? These challenges start right from storage. This is the most important challenge that we need to understand. Then we talked about processing, then cost. We also have to see the scalability. Then storage, processing, cost, scalability. And then we also have to check the existing tools capability. Right? And then also, most importantly, how do we handle unstructured data? And these were the challenges with respect to the big data. Right? Now, the workaround that was identified by the industry was to work with horizontal scaling, right? It's horizontal scaling. Now here we extend multiple computers which are interconnected together, right? This is the work around. Now, using this concept, organizations like Google, right, have come up with distributed framework concept. So initially they started with map reduce concept. Now this is distributed computing framework which was initially launched. Map reduce basically has map functions and reduce functions, right? It has map jobs and reduce jobs. It is written in low level language, right? So this is basically, yeah, map reduce function. It was initially started with Google. Later on, HDFS was created. HDFS is distributed storage framework, right? And here we'll have file system which works underlying on top of the underlying file system, which is Linux file system, right? So these are the two components, but managing this was a little becoming too tough. Hence, Hadoop 2.x started with Yarn, which is a cluster manager. These are the components that we have that are defined for Hadoop, right? When you say distributed computing, it's nothing but Hadoop. And these are the components of Hadoop. Yeah. So distributed framework is the solution. Now Hadoop comes with master slave architecture. And this master slave architecture is supported by 5 daemons, or they are also known as services or Java background services. Right? These are Java background services. And these services, these 5 services are name node. You'll have a single name node at any point of time. Then we have data nodes. We can have more than one data nodes. We can have secondary name node. This basically is backup of your metadata. Then we also have resource manager and node manager. These were also called as job tracker and task tracker previously. So if I talk about components, then these are the components. Okay, let me just drag them here. Yeah. So these are the components, these are the services that we have, master slave architecture. This is about your Hadoop. But Hadoop, to understand at a high level, Hadoop is a framework. We can also call it as an operating system. Can be understood as OS for multiple interconnected computers. Here, at a very simple terminology, we can say it can be understood as an operating system for multiple interconnected computers. Right? This is about Hadoop. Now we have talked about Hadoop's capability with respect to dealing with big data, right? It supports parallel and distributed computing. It allows the software to be installed on commodity hardware. Right? We don't need a very high configured servers. That's the beauty. And it is open source and free. Right? So parallel and distributed computing, commodity hardware. It also has fault tolerance. Write once, read many. It is reliable. And the important feature, scalability. It is scalable. Now, in order to achieve these, I should say, the features, it has certain characteristics. Right? It has certain characteristics. These characteristics basically are replication. The replication factor by default is 3. Right? It copies the files, but before copying, you need to understand that it has the feature of partitioning the data, right? So the block, it partitions the data basically. And when we talk about partitioning, each partition, each split is called as block. And this block standard is 128 MB. Right? The least minimum block size that we can go is 64 MB. Remember that. Okay, these are the important characteristics that we need to look at. Next. We talked about the Hadoop ecosystem tools, right? We talked about Hadoop ecosystem tools. Or we can also call it as projects. Okay. Why we look into this is because your Hadoop MapReduce framework is basically having low-level programming abstraction. That means you have to write low-level programming, right? But a lot of people don't know coding. People who are functional experts, they don't know coding, right? So here we have high-level abstraction, programming abstraction that was created for people who are non-programmers, right? Industry requires functional experts to work on the data, right? So hence we talk about this ecosystem, and this ecosystem, basically the projects here are developed thanks to the component called Yarn, the cluster manager that was, right, basically later on developed. It allows third-party tools to communicate with HDFS, right? MapReduce and HDFS components. So as part of this ecosystem tools, we talked about Apache Pig, Apache Hive. Pig is a procedural language, and here schema is optional, right? It can work with structured data, unstructured data, semi-structured data. It can also execute in standalone mode. It can execute on MapReduce mode. You can execute the code interactively. You can execute the code by creating scripts, right? A lot of flexibility is there. And the codes that we are writing are high-level programming abstraction. I mean, they're written in high-level English-like commands. Hence, it's called as procedural language. And this PIG was specifically developed for ETL tasks, right? It is ETL tool on Hadoop, right? This is ETL tool, and the ecosystem tools that we have on Hadoop, they work on MapReduce framework only, right? So what happens here? The pig commands right are compiled into map and reduce jobs. Map and reduce jobs by the compiler itself, right? And then these map reduce jobs are getting executed on top of your HDFS. Similarly, we discussed about Hive, and Hive is a data warehousing tool on Hadoop. It's a data warehousing tool on, right, Hadoop. Then we have very important feature in your Hive is that it is SQL on Hadoop. It is used for data warehousing, but we can say it is SQL on Hadoop, right? Then we also have schema on read option. That means when you are trying to read the data which is already there on HDFS, right? When you're reading that using Hive, you'll have to give schema to it. That means you have to give structure to it, isn't it? Right? So schema is on read. Okay. Yeah. Yes, Abhishek, it's one of those ETL tools. Yes, that's right. Okay, so we discussed about Pig and Hive. You also have Teradata, right, Abhishek? That is also an ETL tool. I mean, there are multiple companies and different organizations come up with these tools. Talent is one such. Okay, now we covered this. Till here we covered, right? Now today we are going to talk about HBase. This is distributed database, friends. Now when we try to learn database or when we try to learn database software is when I talk about. Traditionally, we have RDBMS systems, right? When we talk about RDBMS systems, these systems need specialized hardware, right? They need to have specialized hardware, specific pre-configured your setup basically, right? And they only work on tables. That's basically means you need to have structured data. Now, if I have a huge data, organization's data, mind you, why not I keep them on Hadoop itself? Right? You might say that, hey, Hadoop was, we're discussing Hadoop to make sure that we are storing the data, organization's data, right? Obviously, that's correct. But if I talk about Hadoop, remember we said it is an operating system. Now, when we talk about Windows or any other Linux or Mac systems, we have a standalone operating systems. Then here for this, you have a file system, NTFS, or for your Linux, we have XFS, etc. Why not we store data here on the storage device itself? Why we need specialized softwares? Yeah, why do we need RDBMS, friends, when we can store the data? Yeah, anyone? You have a Windows computer, right? Now, you are given organization's data. Okay. Now, why not you store on your hard disk? Why you need some software? Why you need this database software? Anyway, what is the need of having RDBMS? Yeah, people, you might have attended training, database management systems training. So to retrieve data, can I not retrieve data from hard disk? It stores in table format, okay, in structural format. But I might have various other types of data that I cannot store in this software, right? In fact, that becomes a disadvantage. How does it become advantage? Think. When you talk about hard disk, guys, not really. Let me explain. You have a data, okay? You have some data. Right. That's right answer, Saurabh. So imagine this, guys. I'm giving you some data file, okay? Some file. It has multiple records in it, right? When I give that file to you, you are going to store the data into your hard disk. That means you are just copying the file as is into your hard disk. Now, will I be able to read records in this file directly? If I store the data on hard disk, no, right? I need some other software anyways to open the file and read it, right? I have to open the file using some software. It could be a text file or a notepad or Word document or anything. but I need some software to open the file. Now, when I open the file, I'm saying there are a lot of free softwares, I can use them to open. But the problem with these softwares is indexing. You cannot quickly look into these records, right? If you have to retrieve any specific record, you'll not be able to do, right? Exactly. We can talk about CRUD operations. That's right. Yeah. So when we talk about the SQL software, that is your RDBMS, this was dedicated, specifically developed to do this CRUD operations, guys. Okay, create, read, update, and delete at record level, mind you. Okay, to understand the concept, let's say if I give the same data to your RDBMS systems, then what does this RDBMS systems do? They do not take the file as is and store. No, the software takes records and stores them in some table. Now, when you want to access this, you directly access the table. And you have indexing, you have primary keys and all those right things which allow us to quickly look into the data and in fact retrieve the relevant information, right? That is the reason why we need these softwares. When my database is increasing, when my data is increasing, it makes sense for us to manage the data using operational data using RDBMS. Okay, it's specifically developed for handling operational data. Your RDBMS softwares were specifically developed to handle operational data. Okay, transactional data, which is always in structured format. So that's specific reason why it was developed. Now, when we talk about operational data, these few decades ago, it was only transactional data, right? Structured data. But now in the operational side of things, the transactions that we are seeing are generating unstructured data also, right? So we need to manage those unstructured data as well. So to start with, just like how I have Windows operating system, organizations invented Hadoop. Okay, this is also an operating system, but this is operating system for distributed environment. It means multiple computers which are interconnected together. But if I try to store the data, because HDFS is there, we will store the data. Splitting, storing, and all that happens. But if I have to access any single file or record in a file, I have to navigate the file, then read the file, right? So it takes a lot of time, and you'll not be able to do meditations on that particular. The rise of HBase happened, which is nothing but data software. NTFS, if it is Windows, it is NTFS, if it is AFS, right? But the requirement for Hadoop specifically was to handle structured and unstructured data. Structured data is already being handled by this. You don't need a specialized software for that, right? When you're trying to create something new, then you need to have a feature that it can also support unstructured data, right? Now, because this database software that we are talking about, the HBase software that we are talking about, is going to sit on top of HDFS, which is distributing the original data, right? If I have one single file, remember, it gets split into blocks. This is one block, this is one block, this is one block. Same way, if I have a single table, right, a data, which is very big, to get stored in a single system, then the table also has to get partitioned, right? Each part is that on HBase files. Yeah. Are you able to hear me now? Okay, wonderful. Right. So we are talking about Hadoop, HDFS, and on top of HDFS, the database. Now, this HBase is the name given for the database that was designed on top of Hadoop operating system or Hadoop framework, where the data gets distributed, right? And this HBase is a column-oriented database. It's a column-oriented database. What does column-oriented? We'll try and understand that in the next slide. We deal with columns in HBase, remember that. And of course, it is open source, it's free. Okay, and it is non-relational database. Your traditional systems, we call them as relational database management systems. But HBase, we call it as non-relational. Right? That means between tables, there may or may not be relations. You don't have to have relationships between tables. Right? Then we have column-oriented. The data gets distributed. Within the software, the tables that we have, those tables get distributed physically and stored in different systems. And it is scalable. Just like your Hadoop, it's on distributed framework, right? So it can be basically scalable. Now, HBase, because it has to support unstructured data, right? It will have the flexibility of schema, right? It is basically having flexibility of schema. What does schema means? Remember, we discussed about schema. What does schema means? What does schema means, guys? Tables, no. Schema is not tables. Structured data, no. Okay. Schema is the definition of the structure or definition of the table. This is like a blueprint of your table, right? It's a definition, logical definition of data. Yeah. That means for your table, you need to have the schema upfront defined for you to call it as a structured data. But here, because HBase has to support unstructured data and semi-structured data, it gives you that flexibility. You can define that, right? Then what does this auto sharding means? HBase is supporting auto sharding. What does that mean? Yeah, anyone, what does auto sharding means? No one? Partitioning. No, it means partitioning. Sharding means partitioning. It allows you to basically automatically partition. That HBase supports that automatic partitioning. Because it's lying on HDFS, right? And HDFS splits your data. Physically, it splits the data into blocks. When you say physically, when you create table, even table is nothing but a storage, right? It carries some data and you have to ultimately store it on disk only, right? If this table size is greater than, right, your block size, then it has to split 128 MB size physically. That means you're splitting the table. So it automatically supports sharing or sorry, sharding. That means partitioning. Yeah? Yeah. Yes, Abhishek, that's correct. Because it is lying on top of HDFS and HDFS deals with 128 MB blocks. You cannot have a table which is greater than 128 MB block, right? A single block of table cannot be more than that. So it is automatically doing that. And HBase is on top of HDFS and it provides low latency, random, and real-time read and write access to your data points, your records. Whereas if you talk about HDFS, it can not do, I should say, read, write, or retrieve the data immediately. HDFS have high latency in reading the data or writing the data within, right, your data file. Within one data set, you cannot read immediately or write immediately using HDFS, where HBase allows you that. Right? It's a database, it allows you that. It is also known as NoSQL. NoSQL means it's not just SQL, not only SQL. That's how it is, right? Latency is delay. Latency means delay. These are the summary of these are the features summarized for your HBase. It is non-relational. It has flexi data model. That means the schema is flexible, and it is scalable. Okay. When I say scalable, your tables can grow, right? Just like how we have the regular tables that as and how your new data comes up, you create the data, right? Records. So it is scaling up. So here also your HBase allows the data to be scaled. Okay, there's something called as regions and region servers. We'll try and understand them. Then this third point will be clear for you. So just to brush up, SQL is nothing but structured query language. It is the language or a medium which allows us to interact with the data which is stored in these systems. These are a few examples, right? Oracle, MySQL, MS SQL Server, PostgreSQL. These are probably the most popular ones in the industry. Then when we talk about non-relational database management systems, when you say NoSQL, then this is a language or this is a medium used for databases which deal with unstructured data as well, right? It basically allows us to add the schema. That means schema is dynamic here, right? And these type of databases, NoSQL type of databases can be column oriented, that is like our HBase. We can have document oriented, we have graph based, right? Or we can also simply have key and value pair storage. And HBase, as I mentioned, is the first of its kind of database, which was designed on top of distributed databases, distributed framework, right? We do have MongoDB, Bigtable, Redis. These are other examples. And MongoDB is another very popular database in NoSQL side of things. That's a quick comparison between SQL and NoSQL. So when I talk about SQL, the traditional RDBMS uses this query language. NoSQL database systems, basically it deals with different types of data, and it generally is handling big data applications, whereas SQL is regular data. It is structured always. Here you can have structured or unstructured as well, flexible. Right? When I say structured, of course, it has predefined, and this is dynamic. We can alter them. The schema can be altered. Whenever we talk about SQL databases, the first thing is tables. But what is table? When I talk about a table is nothing but collection of rows and columns, right? It's nothing but collection of rows, where each row is having multiple columns, fixed number, of course, but it has multiple columns. Now, when we deal with SQL databases, the tables can grow row-wise. You can add more records, right? That's how your SQL tables are designed, row-oriented. Whereas in HBase, the HBase is column-oriented, right? That means we can scale as many columns as we want. We can scale up the features of the table. Hence, it's also known as horizontal scaling, whereas this is vertical scaling, right? This is not suitable for hierarchical data storage, whereas this is suitable for hierarchical data storage. Here, SQL requires specialized hardware, clusters and all that, whereas NoSQL does not require all that. You can use your commodity hardware as well, like HBase is one example. Next, this is again, as I said, a quick comparison list. Let's deep dive and understand how does column-oriented databases actually work. Yeah. So table, as I mentioned, table is nothing but collection of rows. One single row is collection of multiple features, right? Those features can be segregated and we call them as column families. And within these column families, you will have multiple columns, right? Yeah, multiple columns. But what is a column? Column is nothing but a key value pair, guys. Yeah, column means you have a header, column name, and then value to that column. This is basically your table, right? Column families probably is a new terminology for you people. When we talk about RDBMS, you don't have something called as column families. You only have columns. Now, if you look at this employee table, right? If I talk about employee table, in employee table, I'll have multiple fields, right? Like employee name, employee designation, organization, what is his salary, so on and so forth. At the same time, I also have what is his location, whether he's married or not, what is his address, etc. So can I segregate this data that we have for employee into sections, into groups. Now, the example that we are talking about here is having two groups, assume. One is personal information, the other one is professional information, right? So my table can be segregated into two groups. In each of this group, we have certain data which is similar, right? We can give a name to this group, we can give a name to this group, right? And we basically call it as column family, right? Now, when we read the employee details, when I talk about employee details or employee table, I will talk about an employee I. So when I look at this employee I will talk about his name, his location, designation, salary, so on and so forth. This is how you look at the regular data, right? When we talk about regular database, this is how we see regular database, isn't it? Now, if I talk about, let's say, column oriented data here, what is this field? What is the salary field? Salary basically is a float, or in simple terms, it's a decimal values. It contains decimal values, right? And for a computer, reading this field will become easy rather than reading this row, because I need to interpret different data types, right? First, name is basically a string, then city string, designation string, salary integer, then I also might have a salary float, then I also might have age, years of experience, etc., etc., etc. So for each field, we have a different data type, isn't it? So a row, if I have to access, I need to access so many different data types, right? So it takes time. It takes time in reading all the values. But rather than doing that, can I store the values from columns perspective, right? All I need to do is have a row key. When you're storing the data or when you're accessing the data, all we have or we need to have is a row key. And then we go to, row key is like an index, okay? And we go to that specific column and try to access the specific row. When we read the data, we read only one data type, right? Salary. Salary means what? It is a float type. So I will only read salary, right? So my accessing becomes, my data read and write operations become easier and much faster. Yeah. And if I have to bring in more fields, I can add those fields into these column families, or I can also create entirely new column family. So my column oriented database can scale wide with respect to columns. We can add as many columns as we wish. But in RDBMS softwares, once the structure of your dataset is designed, you cannot. So what you do, you create another table, try to have a relationship between the new table and the old table for accessing or creating the entire profile of that particular employee. Is it making sense, guys? Yeah. Am I sounding sensible, or you are losing everything? Hope you are able to follow. Very good. Wonderful. So this is column oriented, guys. Very simple. We have data in columns. Okay. That's a comparison between row oriented SQL tables and column oriented HBase tables. Now, how is HBase different from HDFS? HDFS is the file system, right? It's a file system where we store the data. And HDFS is basically splitting the data and then storing it into physical systems. Now, when we talk about HBase, HBase is a software which is residing on top of this file system, right? It is a software which resides on top of the file system, right? Now, HDFS does not allow reading individual records. It takes time. You have to open the file and manually read. Whereas HBase, you can write queries and retrieve only that record that you are interested in. So we can very quickly read the entire table. All you need to know is row key, right? So it has high latency. HDFS has high latency. It takes a lot of time. Whereas HBase, low latency, because you can directly access to that one single row. Directly you go there. Now, you might be wondering, the same thing happens in RDBMS also, right? When I want to retrieve some table, record in a table, what I do, this is my table, right? Let's say I want to identify a specific record. Let's say I'm one of the employee in this organization, and this is the employee table that I have. And I want to read my details somewhere here. This is my record. Okay, 1, 2, 3 is the ID. On certain condition, I want to find this record. So what we do in SQL, the retrieval query, select query that we are talking about. Everyone understands select query, right? Simple terminology, I want to select that record. Okay, select something. So select query is a retrieval query, and I'm writing some condition to retrieve the data. Okay, on select record or records on some condition. Okay, some condition, whatever it is. So SQL is going to go in sequential retrieval process. That means it comes here, accesses the data, this table, takes the first row. When I say take the first row, it reads the entire row. It reads the entire row into your swap, temporary memory, right? Reads the record and then verifies the condition. Verify for the condition. If the condition is satisfied, then your result is obtained. But if your condition is not satisfied, right, then this exercise that you have done, reading the entire row, is wasted, right? If I have 100 columns, every column has to be retrieved. But remember, my condition will be on a single column, not on all the columns, right? So wastage of time, wastage of memory. Now, in column-oriented databases, what happens is, what is your condition? We try to access the table, but based on the condition. So let's say this condition is defined for this X, that particular column. Okay, assume. So what your HBase does is, it reads the entire row for that particular column, only that particular column, mind you. We don't read all the values. We'll have something called as row key, which is nothing but indexing. So we take one and then verify the condition. Then two, then three, so on and so forth. Wherever this condition is verified or satisfied, using this row key, we try to access the complete row. Right? All the fields of that particular row are retrieved. Now, what is happening? See, here, every time I'm reading one row, I have to read so many values, right? First you read and then do the query, right? Whereas here what we do, we read the data, but only one value. That means I'm reading only this column and then doing the verification, right? And when it is satisfying, that is when I read the entire row. Till then, I'm not reading the entire row. Yeah, making sense now? Why it is little faster? Yeah, so internally it has hash tables and right indexing and all those things done to map to the rows. This way, it allows us to go to that specific condition and apply the condition rather than reading all the columns. Read that one column and apply things, and then everything falls in place. It's very easy. Quickly, you're satisfying the rows, identifying rows which satisfy the condition. Right? This is how HBase works. Now, just like how we have components in Pig, components in Hive, we have components in HBase also. Now, we'll not look into all these components, not required. What we need is only the HBase components, not the entire architecture. Okay. HBase is also a distributed software, right? Distributed framework software. We call it as distributed database. That means it also should have master-slave architecture. Remember that. Okay. So this is your master, H master. And this is like any other master in master-slave architecture controls the operations. Okay. Next, on the slave side, these are the things which basically work. So you have H region, then we have H region server, then we have mem stores and H files. We also have write ahead logs, vals. Like in HDFS, we have edit logs. Same way here we have WAL, write ahead logs. Right? Yeah. Now, it also uses a component called zookeeper, friends. HBase is also using a component called zookeeper. Right? Now, what is that zookeeper? Let's try and understand. Okay. So these are various components that we need to discuss now. Let's see. And ultimately, your data is lying on HDFS. Remember, distributed framework. Right. So we have master, region server, and then regions within that region server. Then we have memstore, H files, and vals. Right? These are the components. H files are the physical blocks, right? Data blocks. They're physical data. H file, data file format. It is nothing but the data block. It also has might have meta block. It means information about the data. It might have file info. It might have index, right? So these are all the different things that we might have in H file. Basically, this is a file that is used in HBase, right? And HBase, remember, is working on HDFS. So partitioning is something HBase should support, right? And by default, HBase comes with a block size of 64 KB, right? This is the minimum block size. Not minimum, default, sorry. The minimum can be 8 KB and the maximum can be anything, and it is recommended to be 1 MB. You can also have 128 MB as well. Yeah. So this default block is 64 KB, right? But we have somewhere between 1 MB, right? Close to 1 MB, I mean minimum. That's what we basically have, right? And this block size of HBase can be also defined, configured on the HBase-site.xml. It's a configuration file, just like how we have hdfs-site.xml, wherein we define the block size, replication, and all that for Hadoop. Same way we have HBase configuration file in which you can configure the minimum block size for your H files. H files are, remember, physical files which contain the data. Okay. But how do we get this H files? So let us try and understand the regions, region servers, and all that. First is master server. It's like name node. This master server assigned basically is assigning region servers with regions. Now, regions are nothing but tables. Region servers are nothing but your data nodes, slave nodes, right? So master server assigns regions to the region servers using Zookeeper. Okay. And master server manages the load balancing, the balancer, right? We have that. Maintains the cluster status for scheduling the tasks and all that, right? And load balancing also. And all this is being done via Zookeeper. Okay, there is a component called Zookeeper. In the next slide, we'll talk about that. As I mentioned, regions are nothing but tables. Okay, your data. Whereas region servers are the data nodes. Like these are the slave nodes on which you have the actual data sitting. Right? So these are the servers where read-write operations happen. That means the tables get created. Okay, so we have regions. These regions are part of region servers. Okay. Then what is the Zookeeper? The Zookeeper, it is basically a software which allows us to do coordination between different, I should say, slave nodes, slave components, right? In the distributed environment, we'll have multiple nodes, right? For processing, we'll have multiple nodes. So Zookeeper manages them, right? It allows us to coordinate with them. So it's an open source project. Zookeeper is free, open source, right? And it tries to maintain the configuration information about your nodes. Yeah. It tries to help configuration for your basically the various services that we have in your distributed environment. Yes, Ashna. Yeah, go ahead.
Sir, for the Zookeeper, it's like an API. Can I say it something like that that connects the master to the slave? It's like that there's an API between and Zookeeper, or no?
Yeah, you can say it is an API. It's like a product. You configure these services within Zookeeper, but yeah, you can say it is like an API. Yeah.
Okay, thank you, sir.
We will be installing Zookeeper just like how we install Apache Hive or Apache Pig.
Mm-hmm.
It's just like another software which not just supports HBase, but any other distributed service as well. Okay, it basically coordinates between the master, the slaves, based on the request that we get. Right? So it's like a device which allows us to coordinate. Zookeeper, you can see it's trying to maintain configuration information, naming information, and allowing the synchronization, right, of your services on cluster. So the ultimate logic is it allows the various services to be easily managed, right? The goal is to achieve more reliable and simple way to use these multiple services that are available on distributed environment. That's the logic of Zookeeper. Then we also have something called as memstore. Yeah, memstore is nothing but memory location. The memstore is a write buffer. We call it as write buffer. It is nothing but memory location. So when I want to write some data onto your HBase table, then it doesn't directly get written onto the physical location, right? It doesn't get written on your HDFS, right? The table, but rather the content is first written in this memstore only, right? It is a memory location where the data is getting written, right? But when this memstore fills up, that is when the data is getting pushed into the H file. H file is a physical storage, right? On the disk we store. But this H file gets created when memstore is completely filled up. Yeah. And these basically when flushing the data into H files, they create every flush, we create a new H file. Okay. And we define the H file size, right? So memory, memstore, when you're having the data stored in memory, and when it is trying to push the data into physical storage, it basically pushes it in 1 MB size. Yeah. Now, one thing you need to remember is that H files that we are going to create, physical H files that we are going to create, they're always going to contain information from a specific column family, right? One column family, one memstore. You can have multiple memstores for your column family. That means you can have multiple H files for your column family. But within one H file, the physical location, you cannot have columns from different column families. So the data is physically also getting segregated in such a way that retrieval becomes easy. Right? Because the access of these fields is via column families. First, you go to a segment, column family segment, and within that column segment, column family segment, we capture one specific column. Right? So storage of your data is happening in an intelligent way, where when you're accessing a single file, H file, you will get specific column families only. You not get mixed data, mix and match data. Right? So that's how memstore is designed, or memstore helps HBase configuration. And in HBase, these are the 3 different types of files that we have. We have already discussed about H file. This is also nothing but data file. We have links. There's something called as links, memory links, which basically maps the data files with your memstore. You can say that it is mapping the data files with memstores. Then we also have vals. Val is nothing but write ahead log. What does this write ahead log actually means? So when HBase is being used, when we want to create some data in HBase, the data that you're trying to write into HBase table will first be recorded. I mean, the instructions are recorded in your logs. First log gets updated. Post that, the data records are getting updated in your table, HBase table. So before we write the data physically onto the table, that is your HDFS, val gets written. And that is, of course, that is the reason also why it is called as write ahead log. Before you writing the data, you update your log. Right? That's the reason why it is called as val. Now, data node fails. No problem. Because underlying the HBase is working on your HDFS or Hadoop system, which basically handles data node failures, right? Using replication. So even if your data node fails, no problem, because your HBase provides replication, right? Any block that you are writing will get replicated. That means the data in HBase, the tables that we have created in HBase are also getting replicated. You don't have to specifically design something in HBase, right? Now the replication factors and all that in Hadoop, they are defined in this HDFS-site.xml, right? Right, and yeah, this HMaster, regions, region servers, all those things are being coordinated, or basically Zookeeper is coordinating between them. Okay, that's the work of Zookeeper anyways. Now, this is what actually happens when we are trying to write something in HBase, right? So the first instruction is update your val, write ahead log, which is also known as H log. Okay, write ahead log or H log. Then that information that you want to update on your HBase is first getting written into memory. That memory is called as mem store. We call it as mem store, memory store. Now this mem store is of fixed size. Okay. Now when this mem store reaches certain level, some threshold, maybe 80% or 85% or something like that, then the entire data that it contains is getting pushed into physical file. This is memory block. This is physical file block. So data gets flushed to the disk. Right? It is also called as data file, or it is also called as store file. This is how the data gets written. First goes to memory, then comes to the physical file. Now in HBase, we also have a feature called compaction, which allows us to merge these H files. We can create a larger H file by merging them. This is a feature which is called as compaction. We can do that in HBase. So these are basically the high-level features of your HBase, which is nothing but a database on your HDFS. Right? Installation steps are given. The practice steps are also given. Shall we do this practice, or shall we skip the hands-on and go to Spark? Your choice, guys. What do you want? You let me know. Okay, one is saying skip, one is saying practice. Okay, I'll do one thing. I will just show the installation, and I will walk you through the installation the practice steps, and you guys do this. This is very similar to your SQL commands, right? So let us try and look into the installation steps. Okay. Yeah. So you have to first download HBase file. Now, in order to download HBase file, we'll go here. Yeah, remember I said these are just theoretical concepts, Abhishek. They're not covering in detail. All right. So here, let me talk about downloading the HBase file. Again, these are Apache managed open source softwares, right? So you'll have Apache website. So you can say Apache HBase download. You simply say Apache HBase download. It goes to hbase.apache.org. I go to the home directory here, or home page, and you can see this is the home page. It says it's a HBase is a Hadoop database, a distributed, scalable big data store. Right? When you need random real-time access to your big data, okay? Very large tables, billions of rows and millions of columns can be managed using your HBase, right? So here to download, we click on this download link. Click here to download. It will redirect to us to the download page. And this is the software that I have downloaded, 224. Now I see 226 is there and 234 is also there. Let's go to 226 only. We'll stick with this, right? Here we can go with, let's say, bin file. Where is the, yeah, mirror sites, Apache archive. Let me go here, and you can see so many different versions are given for us, right? So many different versions are given. Yeah, but yeah, it's too confusing there, so we'll come back. You might want to go there. Yes, you can go for the archived versions. Now we are going with 226, right? So let me go to bin link. You see bin link. You can also go with the stable release, which is 234. Okay, you can go there also. Let me click on this bin. It redirects me to this bin directory, right? Or bin location. And this is where you're going to click to get your file downloaded, or you can also remove this and go to that specific location. It's not going there, is it? Okay, let me click on this. Yeah, this is the link. And here we are trying to download this file, which is 259 MB. Right? When you click on that link directly here, it's directly taking me to that location. Yeah, bin location. You can click on this and you'll be able to download the software. Okay. Just like the other softwares, here also. Okay, you want the link, huh? Yeah, there you go. Yeah, just like other softwares like Hive and Pig softwares, here also we will have to update the bash RC. Right? The first point is your path variable, and for path variable, to make it easy, we are having HBase home. So first define your HBase home and then define the path column. You also need certain predefined libraries which allow HBase to work on top of Hadoop file system. So there are few of the jar files which are defined in this location. So we are going to give the details of that location to class path variable, just like path variable, we have another system default variable called class path. This allows the jar files and all those things, right, to basically identify jar locations and all that. Dependencies, basically. So we have to give these three values in bash RC. Okay. Now, once that is done, we come to the HBase/conf location. Once you extract this folder, you get the HBase software. Inside that, we have conf folder, like we have hive_home/conf. Same way, we have HBase home/conf. Within that, you have your HBase-env software, where you need to make sure that the Java_home is properly set. And then we also have to define the zookeeper.
Sir, question.
Yes, please.
For this one, HBase_home/comp, is it already set there? For example, in that env.sh, if we edit it, is the text set Java home already there? We just need to uncomment it, or are we going to add it manually?
It will be there. It will be commented, but we need to make sure that you remove the comment and point it to the right location.
Okay, sir.
The version upgrades, we are not sure, because they might automatically design to pull the installation, Java installation that we are doing. So we don't know unless until we see, we don't know. But what we are saying is we have to basically define these 2 points to your HBase environment, because it has to work on Hadoop, right?
But this Hadoop home is commented out here, sir. So do we need to comment it also there, or because you see it's hashtag?
Okay, it does not mean hash. Basically, I'm saying that it has to be defined. If it is already defined, fine. If not, you might want to define it. Even if you don't define it, no problem. If it is commented, you can ignore Hadoop home, because HBase is going to use the standard name Hadoop_home, which is already defined in our bash RC file, if you remember.
Okay, because from what I know, the sh file, the hashtag means comment there.
Yes, yes, hash means comment. That's right.
So I'm not sure if we comment it out or we uncomment it, what would be the effect? So would it be no effect?
There will be not much of effect, but there is no effect in fact. See, ultimately for HBase, it needs to know what is Hadoop. Where is my Hadoop? Right?
So if we comment it out, we won't it will automatically know where's the Hadoop, even if it's comment out or even if
Yes.
it's comment in. Okay.
Yes, yes, yes. Because it is reading the environment page. That is your bash RC file. There, anyways, we have defined.
Okay, sir.
Yeah. You might want to experiment on that, right? So just check what happens if I commented, what happens if I uncommented. There will be no change. All right, next. This is another setting that we need to do in the same file. Right? This is basically to set your zookeeper. Now, by default, HBase comes with an inbuilt zookeeper. Generally, zookeeper is installed on Hadoop clusters for better configuration of your distributed environment, right? As a separate tool. Now, if you have something of that sort, when you have a zookeeper installed separately, you don't need to give this true. You can say false. That means you are manually setting HBase services to a pre-installed zookeeper. If you say true, which is default value, your HBase comes with a zookeeper and it is automatically configured to manage your zookeeper. Right? It is commented because we are doing a standalone installation. You don't need to edit anything in that particular variable. This particular variable is, you can ignore it. with the default settings. Okay, default is true. Next, we come to the configuration file. This is the environment file, HBase-env. Now this is HBase-site.xml. This is the configuration file, right? And you can just copy and paste this content into your configuration file, HBase configuration file, and make sure you're giving the right location here, right? And even for Zookeeper, we are giving a location here, right? This is also another parameter which enables us to, I should say, troubleshoot and all that, stream the data and all that. If you don't have that, it generally throws an error. Don't want to investigate and all that. We just copy paste this and start working on HBase, right? If you're using HBase in distributed environment, that means you'll have multiple nodes. On these multiple nodes, if you have to use HBase, then you are saying that HBase is distributed. HBase cluster is distributed. You're saying true. And you are setting your Zookeeper, because Zookeeper will basically coordinate with these clustered environment, right? So you'll have to give that information. But for a standalone installation that we are doing, these settings are good enough, right? And we simply start the HBase services, just like how we start DFS and YARN services for Hadoop. Here we start HBase services and then start using. This is how we launch the HBase shell. Yes.
For this installation for the Zookeeper for the distributed environment, sir, is it comment out or not comment out? I was confused because usually we use hashtag if we want to comment it out.
Which one? Which one?
This one, required only when setting up HBase in distributed mode.
It's saying, right, you require this only when you have it in distributed mode. Then you have to have these properties enabled.
Okay, so if it means if it's distributed mode, I just need to uncomment it.
Uncomment this. Yeah. Okay. It will not be there. You have to copy and paste these values.
Okay, sir. Thank you.
Yeah. Let's see if it is downloaded. Still not downloaded. We should have downloaded this upfront. Anyways, now let me show you the commands also. Yeah, this is how we start HBase, right? And if you see here, status, this is the result that you get when you type status in HBase shell. It says one active master. Right? We don't have slaves. Remember, it is a single node installation. So you'll have only one master. So it says one master. Then version gives the version details. Who am I gives the information about the user, OS user. Then this is how we create table. Look at this. It is a little confusing, but you have to try and figure out this. The command says create the table name. Guys, am I not audible? Audible, right? Okay, yeah. Jyotsna, you have to check your internet connection. Okay. So we are using this keyword called create. Then we have table name. And what do you think these are? These are column families. These are called as column family, not column names, column families. Within these column families, you can have multiple columns. Yeah. So the syntax is create table name, column families. And for every the keyword that you are using, you have to put the quotations. And just use commas. Right? This is how the syntax is. And if I show you, how do we enter the data? Yeah, put command. This is your put command. This allows us to enter the data into the table EMP that we have created there. I'm inputting one field. What is that one field? Column family is professional, and then this is the column. Colon is there, see? Column family, colon, column. And this is the value. This one is the row key. Right? This is a row key. Here also I say personal. This is column family. But this is column 2. This is column 1, column 2. So within the personal column, I have 2 column names. This is the value again. Whereas this one is professional, is a new column family, and for that I have another column. I'll say column family 2, column 1. And for all these, the row key is same. That means my first row will contain personal. Here I will say name, city, then I have designation. This is another, right? Column family, I have designation, and probably I'll have salary. So my columns, 4 columns are segregated using 2 column families for the table EMP. And this is the row key, and I have these values. You can assign the data as your wish. For example, I can put name as 1, this as 2, this as 3, this as 4, or any row key. Right? That means here I'll have name. The second row will have only the city column. Third row will have only the designation column. Fourth row will have only the salary column. It has nothing to do with the other rows. Yeah, like this, you'll have value here, you'll have value here, here, here. If you want to add something here, you can add here just by saying row 1, row key 1. Whereas in your SQL, that is your RDBMS tables, you cannot do like this. You have to give all the values. If you have to upload the data, all the columns data has to be given, right? For a single row, all the values have to give. That is not the case here. We are focusing on one column data at one time. Yeah, when I say EMP scan, I get the result like this. Row key, and we get these values. Right? So like this, we can load the data into the table called EMP. Almost done, guys. So let's see how to install this. Done. We have downloaded. So I'll go to the downloads folder. I will try and extract it using the archive manager. I'll say extract all files, keep the directory structure, and then click on extract, and this gets extracted. Or we can also use tar command, right? I'll take this and go to big data and put it here, right? And open my terminal. I have downloaded the folder, extracted the folder, and placed it along with other softwares. Then I'm coming to terminal, right? Go to bash rc. So gedit.bash rc. Open this file, and at the bottom of the file, you can just add HBase settings, right? All you're doing is copy paste and then edit this. So let me copy paste the bash rc related settings. I'll copy and paste it here. I have user 2, This is big data. The folder name is big data for me. And I have HBase hyphen 2.3.4. You have to remember the names, right? Hyphen 2.3.4, HBase hyphen. And that's my software location. And these two will remain same because it is picking up anyways from this location, HBase location. Save these HBase settings. You can close this. You can source the bash RC file so that it takes the HBase settings. And then we go to HBase home. Right? Here you see that conf folder. You enter into the configuration folder. And within this, you have two files. One is hbase-env.sh. The other one is hbase-site.xml. So let's first open hbase-env.sh. You can see it is commented. Java settings are commented. You can ignore this. Okay. You can ignore this, or you can say Java home. It is pointing to the default open Java that we have. All you can do is remove this and say $java_home. Okay, all you do is Java home is equals to $Java home. This would point to the custom Java installation that we had created or we had installed. And we have defined this Java_home parameter in our env file, that is bash rc file. Okay, you can ignore rest of the settings. You don't need to edit anything, but if you want to go through these settings, you might want to go through once. Okay, it talks about HBase region servers and all those things. All these are default settings. You don't need to edit anything apart from Java home. Right? Next. I should show you that setting also. Yeah, this one. It also talks about whether it should manage its own instance of Zookeeper or not. By default, it says true. Let it be that as true. You're not changing anything, right? Default installation, so we'll not edit that. So the only change, Java home, which is equal to $Java home. That's it. Close this. Next, gedit hbase-site.xml. Open this configuration file. And you see these configurations are given for us. Let's cross-check once. So configuration HBase root directory, do we have that? I don't have that. So what do we need to do? Add that property. So click enter and let us copy and paste this property till property into our HBase file. And we are going to change this to appropriate value. This is big data. And this is also Zookeeper location, where we are saying it is also going to be inside your big data folder. So I have H files and I have Zookeeper values, which I have copied, and let us remove this. Yeah. So these are the three settings that I have added to the HBase configuration location. Okay, that's it. You don't need to add anything. Just for your reading, I'm just giving space, guys. Okay. Right. Once these settings, you're copy pasting and making those appropriate changes to point to the right folder. Once this is done, you can close it. Yeah. So this is all we need to do. Download, extract, place it in a specific location, go to bash rc, update the path variable and class path variable, come to the configuration folder under HBase, edit HBase env.sh file. Even if you don't edit, that's absolutely fine because it is going to pull out the values from bash rc. And then we come and edit HBase-site.xml to give these root directory for your HBase where H files will get created. And for Zookeeper also, we need to give a directory because we are managing the HBase by using an internal Zookeeper. Okay, these are the settings. All we need to do now is start-hbase.sh. Right, this is how we start. Start start-hbase.sh. And all you are going to do is type HBase shell. So here you say HBase shell. It will fail if I'm not mistaken. It has to fail. It's loading. Okay. There's a command called who am I. Yeah, it's working. Right. Then you can say status, you can say version. That's the version. Status. One active master, one servers, right? Then you can also say scan emp. Okay, let me just copy paste this rather than typing. It creates the table, right? If you say list, it will show the table names. I have only emp table, right? List gives us the table, and under the table column, we have only one table, right? We can create emp2. And if I say list, it says emp and emp2, right? Now, if I say scan emp, it talks about the content. I have 0 rows, right? So that's basically how it shows you the data. Now, there is this enabling and disabling of tables if I have to edit anything on this table. You need to make sure that the table is in enabled mode if you want to work with your HBase table, and you can use this is enabled column or function or command to check whether it is enabled or disabled. It will say true. Now, unless until it is enabled, you cannot access the table. Okay. Then we have list namespace. This talks about the database instance, or we can say database. And default database and HBase database. These are the two databases that we have in HBase by default. What are the tables that I have? So the table that we created, it is in default database. If I want to see what all the tables that we have in HBase, you can see it is containing all those system related files, metadata and namespace. So by default, we have two databases. HBase contains metadata and namespace data. These are the tables. Whereas the default database is what the users will be using by default, and we have EMP and EMP2 created in them. It's listing out that. You can also say describe EMP. Basically gives us the details. If it is enabled, it will show that it is enabled, and this is the column family's description. Table name is EMP. Column names, column families, we have professional column family and personal column family. These are the two column families that we have, right? Then let me put this column. Okay, let me just show you. I'm copying, but I would request you people to type in, don't copy paste. Right, so I have created one row. Now if I say scan EMP, look at that. It says one row and we have column as personal colon name. Now what is the value? It is Raj. Now let me show you this. I will add this column, but I will say the row key as something else. Let's say row key is 4. Still gets added. If I say scan EMP, row ID 1, it has personal and name. Row ID 4 is having professional salary, and this is the value. Right? So that's basically how your data can be stored. You can also delete a single value, or you can delete one entire row using the row key. Delete all means all the columns are deleted for that particular row. Right? Now, if I have to delete, then first I have to disable the table. Only then I will be able to delete the table, guys. Remember that. If the table is enabled, I cannot drop it. You can see here, if I execute this, it should throw me an error. Drop EMP. It says error. It is enabled. We need to disable it first if I have to delete the table. Okay. So very simple. It is similar to what you have seen in SQL. Syntax is a little different, but the capabilities and all that pretty much same what we have learned in SQL. All right, clear? Any questions? Right. So we will begin our journey with Apache Spark, friends. Yeah. So tomorrow we will start with Apache Spark. And we will spend good amount of time in Spark because that's what we need to learn. That's what future is all about. Okay. So we'll wind up for the day. Any questions? If no, then yeah, we can wind up. Yeah.
Sir, a quick question since we're already touching HBase. What is the difference between Hive and Scoop?
Okay. See, Hive is like SQL.
Yeah, that's right.
Right?
For the Scoop?
Scoop is a third-party product or a project which allows us to use command line interface, the commands, basically commands which are Java based commands, to import and export data between RDBMS software to big data. When I say big data, you can directly store it in HDFS or you can store it in HBase.
Oh, okay. So it's like
import and export. Yes.
Okay. So just a third party app to export or import data from HBase or Hive.
Not yeah, you can say Hive also. Yes. So you have RDBMS system.
Yes.
This is the traditional database. So organizations have data in this, right?
Mm-hmm.
Now we have big data tools. Now I've set up big data. When I say big data, by default, it is HDFS. I don't have any other software.
Yes.
So I can move the table, the data table, in file format into HDFS.
Oh.
Or I can also move this table to Hive tables. Or I can move this to HBase also. Right? So this is what your Scoop can do. So ultimately, Scoop is basically allowing us to move data between RDBMS and big data platforms.
Okay.
Hadoop. When I say big data, it is Hadoop. So the name is from SQL databases to Hadoop, right? So SQ, and in Hadoop, we say OOP.
Oh, that's a trivia, sir. Thank you.
Yeah. It is only for structured data. Okay, remember that. Import, export, structured data between SQL databases and Hadoop. I'll just walk you through with Scoop probably in the next class. Only theory. I'll explain that. And then we'll move to Spark. All right, friends, that's it for the day.
Sir?
Yes.
Sir, we have assignments no, sir, in that alumnus.
Yes, you have.
Then what
have
about that assignment, sir?
What about it? You have to do it. Yeah.
That means that's what I'm asking, sir. We need to do that.
Yes. You have to.
Okay. Okay, sir.
Sure. But that is by default. It is understood. When we complete something, you have to do assignments.
Okay, sir.
Yeah. All right. Thank you. Good night, everyone. We'll connect tomorrow.